let f of x and y be given as follows, then what is that thing? First off, that thing is the partial derivative. Partial derivative. A partial derivative is useful when you have a function of many variables. For example, here we have two variables, x and y. And so partial derivative takes the derivative with respect to one variable. Let's make this precise. I'm trying to say that partial, and by the way, let me specify how you should read this. So this reads out as partial f, partial x. If I replace this with y, then it's partial f, partial y. Or maybe sometimes I'll say partial f with respect to x, and so on and so forth. Okay, so partial f, partial x of not multi-valued, but multiple variable function is the total derivative with respect to x of f of x, which implicitly means that I fix y. So I treat f of xy as a function of x, and I fix y to be some constant. So y does not really matter here. Now I imagine that if you are here with this exercise, I imagine that you might be facing some difficulties grasping that concept. So what I'm going to do right now is I will replace y by a constant, just for the sake of illustration. So let me write f of x to be equal to x minus 1 divided by x plus 1. What happens if I take the derivative with respect to this? Immediately we use the quotient rule. Don't think that's rocket science. You get x plus 1 squared at the bottom, and then you have x plus 1 times the derivative of x minus 1. So this prime symbol is for the derivative, and then you take away x minus 1 now times the derivative, which is x plus 1 prime. Now the derivative of x plus 1 with respect to x is equal to 1. Same thing we can say here, it's equal to 1. In the end, we get the following. X plus 1 squared remains, and on top we have, it's this negative sign that we need to be careful with. Distribute the negative sign, you'll get x plus 1 minus x plus 1. So these two cancel out, and you get 2 over x plus 1 squared. And that's really the, well, it's not the answer, but this is really the way you should approach the problem. Let me be more precise. So this total derivative is the partial derivative of f of x, y. This is what I've stated here. Very important. Now, I promised that I would plug in 1 as an example, but in principle, it could be any constant. Now, to show this to you, you have to watch me remove all the ones that we've written and replace them with y's. And that will perhaps give us the final answer. So y. Let's agree that the denominator should not change. It's just instead of 1, we'll just write y. Now, let's take a look at this step here. If we take the derivative with respect to x and y is treated as a constant, then the derivative with respect to x is 1. The same we could say here. Now, if that is true, then once we distribute these two signs, we'll get x plus y minus x plus y. And if we do this, we get y plus y, which is equal to 2y. And that is the answer. That is the correct answer. But in the spirit of this problem, you should really be treating this constant that we have as, well, I shouldn't say the constant that we have, the variable that we have as a constant. Sometimes I get ahead of myself with the words I want to say. I need to work on that perhaps. So let me go and work on that. This is it.